Good morning and good afternoon. My name is Brian Foster. I'm a content director here at PingCAP, and I'll be your MC for today's event. In today's webinar, Kathryn Sizemore, a principal solutions architect here at PingCAP, explores proven strategies for building and scaling effective multi-tenant systems. We'll discuss practical techniques for managing and optimizing a single database cluster supporting over 1 million tables, maintaining high performance, availability, and security. You'll also discover real-world examples from companies including Atlassian, Plaid, and some others, architectural patterns for scalable multi-tenancy, best practices in table partitioning and indexing, techniques for efficient resource utilization, and strategies for achieving performance at scale. Now, before we get started, our team is online, so please feel free to drop your questions directly into the chat window. We'll be sure to answer them throughout today's presentation. And with that, I'd like to hand it over to Kathryn. Kathryn, the floor is yours.
Great. Well, thank you, Brian, for getting things kicked off here. And thank you all for tuning in to today's webinar. I'm pretty excited to share this topic with you of how to effectively scale software as a service with multi-tenancy. But before I do that, I'd like to introduce myself and give you a few highlights about my background. So my name is Kathryn Sizemore, and I'm relatively new to the Principal Solutions Architect role here at PingCAP. I'm based in the Bay Area of California, where I live with my Pomeranian Marshall. And I have over a decade of experience in the database realm. I'm coming to PingCAP directly from MariaDB. And before that, I had over a decade of hands-on experience with MySQL and other database technologies, transactional database technologies, as a database administrator, as a cloud architect. I've done a lot of database consulting, especially for software as a service companies, and I've considered myself an open source evangelist, trying to focus on MySQL, MariaDB, and now TiDB. So with that, I bring all of that experience here to this webinar, where we're going to start with talking about some of the software as a service scaling traps and strategies that kind of fall on its face, that software as a service companies tend to use with transactional databases. And then I'll introduce TiDB and how TiDB can supercharge software as a service growth. I'll bring in some real-world software as a service solution examples that are running TiDB today, and then we can wrap up and talk about next steps. So let's dive into it. What are these traps that software as a service companies are hit with as they begin to scale? And really, it's a tug of war of things that can go wrong as SaaS scales. Starting with creeping costs, ballooning infrastructure costs of duplicated storage, duplicated compute, monitoring, operational overhead. It's very easy to balloon that cost of software as a service scaling very, very quickly. Then we have infrastructure complexity. What seems to be very straightforward and simple at a small scale becomes operational and server sprawl with exponential growth of database servers. And then the third main trap I see is performance degradation, where all of a sudden at scale, you get unpredictable performance and can't stick to your SLAs because of resource contention and scaling limitations of those databases. And then I'm going to throw in a fourth here. And it's not really a trap. It's another element that you have to deal with and influences the kind of solutions that you come up with is security risk, right? Your CISO, your security teams are going to be breathing down your neck if you scale to something that is not secure. So it plays a part in solutioning how to scale. So before we get into common strategies used to scale, let's first dig a bit deeper on this cost element, because there's a number of hidden costs or not commonly thought about costs that can creep up very quickly as you're dealing with rapid scaling. The first, right, you've got rapid customer growth. You're going to end up with rapid data growth. And it's not just storing that data and the cost of that storage volume, it's the management of that volume, the cost of, you may have to bump it up to higher IOPS for performance and reliability, and also making sure it's backed up. All of the backup costs and duplication of the backups, and making sure that you are not going to end up with any data loss can be very expensive. Next, and I see this all the time, is the over provisioning of infrastructure and the duplication of infrastructure. This gets really, really costly, but it's usually a knee-jerk reaction to trying to solve for the performance problem. And this used to be something I'd see AWS do all the time. If I had an issue with my Aurora instance and needed better performance, their solution would always be just to double the instance size. That becomes really costly, and you're not going to be using that CPU, that memory, those resources all of the time. So having those over provisioned instances gets very, very costly very, very quickly. Now, operational complexity, maybe some of the ways that you've solved your scaling issue becomes an operational overhead nightmare, where you've got a lot of teams, it's probably human effort, trying to maintain the systems, trying to maintain whatever solution, maybe some manual sharding, or trying to manage the multi-tenancy to maintain performance. It becomes a big headache, and it becomes a big waste of resources, human resources, which becomes very costly. Next, and this one's another good hidden gem, is if you've got a really complex system that you've solved your scaling solution for, it can actually delay your onboarding if it takes a lot of time and effort, or maybe just time, to bring on a new customer or create that new database solution for that customer. If you're delaying your onboarding, you're delaying potential revenue, right? So that's a good one. Next, the amount of human resource drain that is involved in maybe whether it's maintaining that solution that you've come up with, that strategy that you've come up with to scale, or trying to find workarounds when you hit the limits of the database. So I know one customer of mine said they were spending the equivalent of years of a developer time to try and solve for the limitations of not being able to alter the schema anymore. So they'd have to create whole schema solutions whenever new features or things were developed. Really, you want your engineers, your DevOps guys, your developers to focus on what brings in revenue, not solve problems and pain points of scaling. Next, multi-tenant security. Sharing infrastructure can create a lot of security challenges, right? That CISO is going to be breathing down your neck if everything's co-located. But it's beyond just developing that for the application or wherever that security is being placed. It's also managing the audit logs and all things across all the tenants so that you're being security compliant. Okay, now we can get into these strategies. The first one that I see a lot, especially with lift and shift or on-premise deployments into the cloud, is the single database per tenant. And this one, I think, comes from a little bit of pressure from the security or the CISO. If you just isolate every customer with their own database, you don't have the same kind of security issue or concern, right? So security teams love it. Get them off your back. Also, you're isolating each system, one customer, one database. There's no risk of another customer impacting the other customer, right? It's isolated. But when you go from 6 or 10 or 24 customers to thousands of customers, it can very, very rapidly become an exponential infrastructure explosion. And usually with very fragile orchestration that you're trying to deal with. And there's no elasticity, right? How do you grow this? How do you maintain efficiency? It's a big headache, and it's a lot of costly systems that you're spending money on that aren't being used efficiently. And it becomes a maintenance overhead and headache that can drain a lot of resources to maintain. So it really can become a disaster. Now, one of the first SaaS companies I worked for had a mandate to move on-prem SQL Server to AWS Aurora. And as part of that migration, we decided to do a single DB per tenant for all of the reasons I discussed before. Security was off their back. It was what they had used on-prem, so it seemed to make sense as a lift and shift, and they could focus on isolating performance so that customers couldn't impact each other, right? Now, great in theory, but the costs very, very quickly became untenable to the point where I firmly believe that we had to be bought out by a competitor because our AWS bill was going to bankrupt us. So this becomes a very serious issue. And if we go back to our little triad of traps, this strategy is very heavily cost trap, followed by complexity, which it seems so simple at a small scale, but when you're dealing with tens of thousands of servers, it's a very complex maintenance nightmare. Okay, so strategy 1, not a great idea. Let's move on to strategy 2. This is, okay, well, if we're not going to do a single database per customer, database server per customer, let's throw it all on the same server and just separate it by schema or databases on that server, right? So single system, every customer gets their own database, etc. As you add on and add on, you end up with a ton of databases for all of those customers. This ends up with a huge amount of metadata bloat on the system. So, the title of this webinar is 1 million tables per database. That is not possible in MySQL or Postgres. It's just the amount of metadata, the catalog bloat, the painful DDLs, the query planners slow down. I mean, it really cripples your system when you're at scale with this kind of strategy. Queries and performances decline because of that. And then database scale limits, like I said, you can't do that. You can't do 1 million tables in a regular transactional database. And then, of course, what the first one is trying to avoid, the performance potential issue, the noisy neighbor impacts. So what happens when one customer ends up utilizing a whole ton of resources? That one customer can end up consuming those resources and impacting all the other customers on that system, even potentially taking the system down. Now, let's go back to our little triangle diagram here. What pain points are we going to experience with this strategy? Security? Yeah, they're going to be down your back, and you're going to have to figure out how to keep those databases secure and customers not being able to access each other. Then performance, right? The noisy neighbor thing is directly related to a performance issue. And can the system even handle the kind of scale that you need, the number of databases and customers you're going to have to handle? All right, so 2 is not a great idea either. What about a best of both worlds scenario? Strategy 3 that usually comes up is custom consolidation of customer DBs. What does that mean? So for one server, you put a couple of customers there, you put a couple of customers on another, you put a couple of customers on a third, and et cetera, et cetera. Now, what is this impact, right? I've got a bunch of customers on different systems. Well, it's a lot of complex routing logic. How are you going to know where to send each customer as they log into your system? Is that going to be handled by the application? Are you going to have some fancy routing in between? How do you manage where customers get their data from the correct database on the correct server, right? Then manual rebalancing. So what happens when you do have too much load on one server and you need to balance it back out? It's going to be a manual process probably. And then it's very, very difficult to do global queries with this system, which is probably necessary for reports or getting an idea of what's happening across all the servers. It's going to be a big challenge. Now, let's look a little bit more into that manual rebalancing. You move that database here because it's hot, this database there, et cetera, et cetera. Then you're moving those connections and that rerouting logic. It gets really complex. And then you still are subject to that noisy neighbor issue of one customer, one tenant being able to critically impact the rest of those users on that system. Now, back to our triad triangle diagram here. What traps are we falling into? Complexity. This one is hugely complex, and wherever you end up putting the load on the application or something in between or on some database sharding logic, it's going to be a complex nightmare to maintain, upkeep, add customers, et cetera, et cetera. Now, it also has the potential of having performance issues, even though you're trying to share the load across multiple systems, and it doesn't have to be 3. This could be 100 different systems that you've got customers on. It still has the potential of having performance impact cross-customer. And then, of course, cost. What I see this relating to cost as is often these systems end up over-provisioning to accommodate the performance. And so that can become very costly. And the human cost of maintaining all of this or creating that logic, et cetera, et cetera. So all 3 of these strategies fall pretty significantly into those traps. There's got to be another way, right? There is. Introducing TiDB, Distributed SQL for SaaS Scale. limitless scale, performance, and efficiency for modern SaaS platforms. Now, first, what is distributed SQL? Now, to answer that, I have to talk about what existed before distributed SQL, starting with transactional SQL. This is probably what you're using today. MySQL, Oracle, SQL Server, Postgres. It's structured, it's ACID compliant, right? It's atomic and consistent. It's full SQL language, so very easy to query. It's got data integrity. Now, transactional SQL can very quickly reach some scaling limits, which is why NoSQL was invented. And this is the MongoDB, Cassandra, HBase, DynamoDB. It's unstructured and flexible schemas. It's high write scalability, which transactional SQL was lacking. And it has the ability to have very large traffic concurrency. Now let's take this into an analogy. So transactional SQL is like driving a car to work every day. Now again, I live in the Bay Area, so what should be a very simple ride for most smaller communities can very quickly, as throughput grows and traffic grows, become a nightmare where you're in stop and go traffic and a 30-minute ride becomes a 2-hour ride. Whereas NoSQL, trying to solve that problem, came up with a new way to blow past all of that, right? So this is what I'm going to call our electric scooter rental, which I don't know if you've seen these, but they've been popping up in all major cities over the last, 5-10 years, where you can just simply use your app, rent the scooter, and take it anywhere. Well, that allows you to blow past all that deadlocked traffic in San Francisco, for example, and very quickly get to your destination. You can take it anywhere. There's no structured route or road that you have to go on. You can use sidewalks, you can go the opposite direction on one-way streets, you can zoom through parks that you can't do in the car, or even go through your Starbucks coffee shop. I don't think the baristas will like you very much, but there's no structured limit for that e-scooter. There's no need to worry about where to park. You can drive it straight to your destination very quickly while everyone else is stuck in traffic. Now, at scale, cities started to have real problems with these e-scooters. Scooters were abandoned all over the city when people got to their destination, creating lots of eyesores. This is not too bad of a mess of a picture here, but you do take that risk of you may be able to get to your destination very quickly, but when you get there, an e-scooter might not be anywhere near you when you're ready to go back home. There's a lack of structure in this method, where it becomes much more of a challenge to retrieve your data back out of NoSQL. People in analytics or business intelligence tend to struggle with getting the kind of data they want out of the unstructured nature of NoSQL, because remember, it doesn't use SQL language. It's a different dialect that is not really read friendly, like the transactional SQL model. Okay, so we've got our car and we've got our scooter. Let's bring the analogy one step further. So transactional SQL is running your business, right? This is the websites, the standard applications, your ERP systems, your online shopping applications, etc., etc. It's predominantly going to run your business. Now, NoSQL is going to record your business. It is great at ingesting large amounts of data. For example, online applications or forms and documents, this all goes very quickly into NoSQL. So it's recording your business. Okay, I've got the run the business car, I've got the record the business scooter. Now what about distributed SQL? Where does that fit? Well, you can see that both the car, the scooter, the transactional SQL, and the NoSQL have limitations. So there has to be a better way. And enter distributed SQL, which combines the best of both worlds from these two predecessors. We have structured, ACID compliant, full SQL data integrity, while also giving us high write scalability, large traffic concurrency, and being able to really scale efficiently. This is your TiDB. Now, taking this analogy again a step further, this is your high-speed rail solution. So the trains arrive on time, it's got coordinated tracks, it's built for not just scale, but speed and structure. You can move thousands of people efficiently, right past those stuck cars, but with power and reliability. So what distributed SQL brings to database is the consistency and power of traditional SQL combined with the scale, resiliency, and speed of a distributed system. So you get transactions, joins, analytics across a global system that just works. Enter scaling the business. So how does TiDB supercharge SaaS growth? Here is our TiDB architecture. Now, what allows TiDB to be very efficient, cost efficient, and resource efficient is that it separates compute layer with data layer. So first we have the compute layer, which handles the SQL processing, represented by these red boxes. We also have a separate storage layer, which persists the data in a key value format. And optionally, we also have a columnar format for analytics processing, represented by these purple boxes. And last, we have something called a placement driver, which in its simplest form can be described as the brains of the database, represented by these blue circles, that manages all of the system. So what are the advantages of TiDB? Well, growing companies can actually focus on building applications for the future without managing complex data infrastructure management. So, number one, it horizontally scales, something that I can't see transactional databases doing well. It effortlessly scales with automatic sharding that you don't even have to think about. Next, it's very highly available with guaranteed failover and self-healing designed into the system. It can take mixed workloads, which is very cool. It's got the HTAP ability where it can do both transactional and analytical and AI workloads. It's strongly consistent. It maintains that ACID transaction that the transactional databases have with strong data integrity checks and global compliance. Next, MySQL compatibility. This is huge when you're coming from a transactional world, being able to leverage the distributed SQL element of MySQL compatibility and language. It's multi-cloud. It easily deploys wherever you need it. It's 100% open source. You can unlock your business innovation with transparent, community-driven, secure database. And finally, it's robust security and compliance. So it protects your data with enterprise-grade encryption, both in flight and at rest. And we have a number of compliances across all of your needs. Now, one of the features needed for scale is high concurrency, which is the core of TiDB. SaaS performance degrades as the customer base and transaction volume grow. But with TiDB, the TiDB cluster distributes data across multiple nodes and distributes the workload across multiple storage nodes, ensuring a stable performance for each node. Now, the PD, that brain, helps to distribute data evenly, manage those data regions or groups so that there's no hotspots. It can split regions, merge regions, when data volumes or the number of nodes increases or decreases, and it intelligently detects hotspots and redistributes the data when necessary so that you're not having to maintain it manually. It's all automatic to maintain a clean and steady performance. TiDB benefits: you adopt a distributed architecture where the node can handle concurrent requests, and a lot of concurrent requests. And by balancing the data and workload across multiple nodes, it ensures stable database performance and scalability. Next, resource control with TiDB, and this is a big one. The challenge is that SaaS scaling solutions suffer from unpredictable performance due to resource sharing and the noisy neighbor problem. That took out two of those strategies that we discussed earlier. TiDB is smarter. It uses resource control features to achieve resource isolation and prevent those noisy neighbors, and it's pretty sophisticated. With flow control, you can manage user read and write requests based on quotas set for resource groups. So you can create resource groups with some fine-grained elements that allow you to assign to each user how much resource it can take, or how much of that load it is allowed to take off of that server. And then TiKV scheduling can help queue requests based on priority mapped to read and write quota as well. So let's look at that resource group element. So say I have tenant A and I want to create a resource group for them. Tenant A is pretty important. They're a pretty big customer. So I'm going to assign it a certain amount of resource units per second, 4,000, and set it to a high priority. These are two different elements I can set here. Now that allows tenant A to use a bigger amount, that 4,000, of compute IO bandwidth resource. I have another group that is not nearly as important or high paying customer or whatever you want to say. Tenants B and C do not need that many resources. I'm going to give it only 400, right? A tenth of what tenant A is allowed. And so they have that smaller amount of resource availability. It can use a smaller amount of compute IO and bandwidth simultaneously that tenant A can have. And then tenant D, another user group I'll create, is being able to batch. With tenant D, I'm going to say, it can have 1,000 resource units per second, but it will also be able to be burstable. So when the resources are available and tenant D needs that resource, it can burst up to use a little bit more resource when available. Some pretty cool features there to be able to make sure that the noisy neighbor issue is resolved. So let's escape those traps with TiDB, those costs, with one TiDB cluster, which can support millions of tables, with decoupled storage and compute layers that are horizontally scalable, reduce the duplication and the over-provisioning, and only provision what you need, and then have very efficient and elastic growth when needed. Automatically bringing a new node online and being able to remove it very efficiently and easily with TiDB. Performance scaled. Horizontal storage and compute scaling, incredibly important for SaaS scaling. And then that fine grain resource control is vital to eliminating that noisy neighbor issue, giving you noisy neighbor protection. Infrastructure consolidated. One cluster automatically rebalancing itself, built for high availability and automatic failover, and online schema change that actually works and doesn't impact your system. Now, security locked down. End-to-end encryption, fine-grained role-based access controls, and a strew of global security compliances. This solves all of your SaaS scaling traps. One cluster, infinite tenants, multi-tenancy mastered with TiDB. Now let's look at some of our real-world production implementations of SaaS at scale with TiDB. This single cluster has over 1.2 petabytes of data with over 700,000 tables, with a peak query per second of 2.6 million. This is all running on one single TiDB cluster. There isn't a giant fleet of databases to maintain or complexity. It's power and scale of just one TiDB cluster. Now let's look at Plaid. Plaid is a backbone infrastructure layer for fintech, connecting over 8,000 applications to growing network of 12,000 financial institutions, with companies like Venmo and PayPal and enterprises like Verizon and Google, and they're experiencing extremely large growth. Now, Plaid struggled to meet SLA requirements of their customers, and they resorted to over-provisioning large fleets of Amazon Aurora clusters that were growing increasingly complex to operate. They had over 800 Amazon Aurora cluster instances, and they were in a per service, per environment model. They had very heavy maintenance overhead with over 104 minutes of downtime that was necessary to maintain and upgrade all those instances. And that took over 23 weeks of engineering effort to do. On top of that, they were unable to effectively do schema changes, so it was taking them over 1 to 2 engineering years annually just to focus on schema change solutions. They also had very large table write bottlenecks, limiting to 12,000 writes per second. Now let's look at how Plaid relates to our triangle of traps. Cost, heavy cost pain, and heavy complexity, as well as experiencing some of that performance hit. Now, the TiDB solution, they now have 3 TiDB clusters, consolidated multi-tenancy separated by service tiers. So they have a tier 0, a tier 1, a tier 2. But single clusters consolidating all of their tenants in that tier. And their key outcomes, they improved over 5 times more efficiency, increasing of resource utilization with the decoupled compute layer. So much more efficient, no longer over-provisioned instances to be able to support this. And they were able to achieve 0 downtime, which met their goal of 4 nines of uptime for the database. They also reduced their operational overhead by over 25%, with rolling upgrades and automatic failover being very easy with TiDB. And their performance also improved with over 170,000 queries per second at scale with very consistent writes. Plaid is a great success story about SaaS scaling and avoiding all of those traps with a TiDB implementation. Another great customer use case is Atlassian, being able to scale to millions of tables in a single cluster. Now, Atlassian is a little bit different because they are an existing SaaS company with SaaS apps that was creating a new application that they knew was going to require the expansion to millions of tables to keep their one schema per tenant model. No other database on the market could handle that need. Now, to do that with a traditional single node database, it would have meant deploying thousands of instances to accommodate their need, which they really did not want to do. The database sprawl that would have required would have introduced so many difficulties in configuration and scaling and backups and upgrades, just a nightmare. Now, this scenario really hits all of the traps. It wasn't just a performance issue at 1 million tables, it was actually an impossible feat for standard databases. So they needed to make the impossible possible. And then the cost required with that database sprawl and the complexity, it was not what they wanted to do. Luckily, TiDB had the solution for them. They have over 3 million tables hosted and performant in a single TiDB cluster for their solution. And some key outcomes that they've found in implementing TiDB. TiDB can create over 100,000 tables in 4 minutes. They are able to do online schema changes and add indexes to tables on databases with 3 million tables. Adding an index, an alter table command, to a database with 3 million tables. This is a metadata nightmare for standard databases in just 3 seconds. They're also able to achieve 40,000 queries per second with seamless horizontal scaling. And the potential database instance reduction of what they would have needed with Aurora, with TiDB, they require only a 1/100th of what Aurora would have needed. And of course, they get 0 downtime with rolling restarts, and they get super fast backup recovery even with 1 million tables. Another great SaaS success story with TiDB is Catalyst, who was able to boost their SaaS performance by over 60 times. Now, Catalyst had Postgres, JSON storage, and Elasticsearch before finding TiDB. They had very slow query performance with just Postgres and JSON. So in an effort to resolve that pain, they added an Elasticsearch catalog onto their existing infrastructure. That workaround required pre-computing the data and increased the complexity, data storage, and cost for their system. So going back to our triangle, that's a serious performance hit, uptick in cost, and complexity that they were dealing with. But TiDB had the solution. Catalyst chose to use TiDB's cloud dedicated service, which is fully managed TiDB as a service on both AWS and GCP. They were able to unify their transactional and analytical data processing into TiDB, giving them HTAP, and improved their overall query performance by 60%, enhancing their scalability with seamless auto scaling and reduced costs. Also, their online DDL and schema chain was actually possible at scale. Finally, to wrap it up and discuss some next steps, as you just heard, SaaS companies are finding incredible success with scaling with TiDB. They've solved their scaling problems, even problems that weren't possible to solve with other database technologies. So back to our triangle, avoid those scaling traps, control your cost, consolidate your infrastructure, predictably scale your performance, and all while keeping your security CISO happy with TiDB. So I encourage you to try TiDB. After you log off of this webinar, I encourage you to log on to TiDB Labs, where we have a lab where you can test out some of the concepts that we discussed in this webinar with our lab called Practical Database Features for SaaS Applications, that will cover 4 topics that are critical for SaaS scaling. It's only 5 credits, and when you sign up with a new lab account, you get 5 credits for free so that you can take it for free after this webinar. I really enjoy taking our hands-on lab courses. In that demo environment, it will automatically spin up all the containers and systems necessary to have a complete TiDB cluster for you to test and play with. You can also log on to TiDB Cloud, and there's some free credits there as well, so you can try our TiDB Cloud platform. And with that, I'll pass control back over to Brian to help us finish out this webinar. Brian?